Good morning. This will be a continuation of handout number 8 for the Stat 210 class. We left off last class period talking about the chi-square test of independence, and we'll do a couple more examples here during this video. The first example that I want to cover here in this video is example 8.2. It is on page 5 of handout number 8. The research question is posed here in the middle of page 5. And it is asking whether or not there are differences in the opinions regarding marijuana use between the 9th graders and the 12th graders. And again, we'll use data from Fillmore County. That data is here in that table on the middle of page 9. One thing that I'm going to do here is just add across the two genders. So my data, for example, for 9th grade is going to be the 11 and the 3, so I'll have a total of 14 there. If we look at the moderate risk, I'll have a total of 29. For the great risk, 127. So I'm not going to worry about differences between males and females here. I'll just, so I'm going to sum across both males and females. I'll do that for 9th grade, and then I'll also do that for 12th grade. So this data has already been given to you in a CSV format on our course website. It's that one there, marijuana grade data. You can download that and then open that in JUMP. That'll save you typing that data in. So here's that data in JUMP. There you can see the 14. Again, I got that from summing across the males and females, the 11 and the 3. The moderate risk, well, there's the 127 for the great risk. The first thing that I'm going to want to do is order these risk values. Okay, they have a particular order, and we're going to want to maintain that when we're doing our plotting. So to do that, again, we just do a value ordering underneath our column properties. So we'll bring that menu up. Put these in the correct order, so no risk is where it starts, then slight risk, moderate risk, and then great risk. So now when we do our plotting, those will be in the right order. To get the analysis done, it's fairly straightforward. We go underneath Analyze, fit y by x. The response here is going to be the risk level. I want to make those comparisons across grade 9 and grade 12. So we'll put grade in the x factor box. And then the count will go down here in the frequency box. We go ahead and hit OK. Again, this is output that we've been looking at now quite a bit. The top here is the mosaic plot. The middle is my contingency table. And then down here in the bottom is my chi-square test that we'll talk about. When I'm looking at the contingency table, again, I can specify the expected here. Let's go ahead and clean that up. I can get the expected. I'll talk about that again in a moment here. But then I also get these cell chi-squares, or these cell chi-square values, which are kind of nice when you're trying to figure out what is causing me to say that I have differences. So those, again, are from the red drop-down menu under the contingency table. Okay, so let's go back quick into the notes and just talk a little bit about this output. So the research question again here is whether or not I got differences in marijuana perception between grade 9 and grade 12. Here's what the observed data looks like. And then the expected data is going to look like that on the right-hand side on the bottom of page 6. So again, the expected outcomes are obtained assuming there's no difference between the grade 9 and grade 12. And what the chi-square test is doing is trying to determine whether or not the outcomes on the left here, the observed outcomes, are far enough away from the expected outcomes under a no different situation. We talked a little bit last time about how to get these expected quantities. So this 15.31 value, where is that coming from? Well, it's actually a two-step process. I first have to decide or figure out what percent of the people think smoking weed's of no risk. So that's going to be the 26 divided by the 292. So 26 divided by 292, it's about 8.9%. We should put those in here. Let me give me a little bit of room so I can type those in there for you. So let's just do this one more time. The expected for grade 9, no risk, that combination. Step 1, get the percent for no risk. Again, under no difference. So what would it look like if there were not any differences between the grade 9 and grade 12? Well, I'm just going to use that total then, that 26, to figure that out. That 26 down here to figure that out. 26 divided by 292. 26 divided by 292 is 8.9%. 0.089, excuse me. And then step 2 is to simply take, for grade 9, I had 172 people. So grade 9 had 172 people. And under a no difference situation for no risk, about 0.089 should be in the no risk group. So if I take 172 times that 0.089, that's where they're getting that 15.31. So that expected quantity there is determined through that process. And we got to repeat that for all of the cells. To measure the amount of difference between what I see on the left-hand side and what I see on the right-hand side, okay, we're using our standard chi-square statistic to do that. So maybe a little bit on that. So to do that standard chi-square, so our measure, let me just type this in here. Our measure for amount of difference is going to be, I'm going to take the actual number, 14, minus what I would expect. I would square that, and then I would divide all that by the expected. So for that cell, it's actually pretty close to what I expect. I saw 14. I should have seen about 15. So that amount of difference for that particular combination is going to be pretty small. And all that means up on my graph visually is that this red box, right, that's grade 9, no risk, is about the same size as the one over here on the right when I'm assuming I have no difference between those. If I take all of those, so if I go back, that's what these quantities are in the table here. This 0.1129 is just that cell chi-square. The observed minus expected square divided by the expected. If I just scan across and look at all those, we can see that the slight risk groups are very different here. The cell chi-square is quite large for both grade 9 and grade 12 underneath that slight risk category. So just holistically speaking, I have big differences between the observed and expected for that slight risk group. And you can see that over here on the graph as well. That would be the green boxes here. They look very different on the left than they do on the right. Okay. If I sum up all of those cell chi-square values, that's where we're getting the 24.105 number down here in the Pearson chi-square. Okay, so that right there is the total amount, the 24.015, way down in the lower left of my screen. That is the total amount of difference, I guess, between the observed and the expected. So let's slide down to that in our notes. Got that in here somewhere. There's that 24.105 and its associated p-value. Again, in this class, we can ignore, so let's go ahead and just cross off the likelihood ratio one. We're not going to use that one in this class. Learn more about that in a different stats class if you take more stats classes. That's based on a different approach. The one that everybody uses is the Pearson chi-square. Now, as far as the decision goes, we just need to check whether or not our p-value is less than 0.05. So again, I'm using the p-value up here of the Pearson probability value or Pearson p-value here. And that's clearly less than 0.05. It's telling me that it's less than 0.0001, I guess. So I'm going to, oops, sorry about that. The data does support the research question. I do have enough evidence for the research question. So then my conclusion is going to be the same as always. We don't have anything different there. So I'll go back up and grab my research question. Just clear up here on page 5. Let's go ahead and write a conclusion down here. So what would the conclusion look like? We do have enough evidence or statistical evidence to say there are differences in the opinions regarding the marijuana use between grade 9 and grade 12 students in Fillmore County. And that p-value for that test, p-value for that test is less than 0.0001, I guess. So very small. Okay, let's move on to the next thing here down on page 8, it looks like. Kind of a little different test here. And this is called a Cochrane Armitage test. And what that test is for is a test of trend in this plot. So we can anticipate, and we can see in this graph also, that when they're 12th graders, their opinion about marijuana use is slid back on that scale a little bit. So there's less here in the great risk when they're 12th graders than in 9th grade. Okay, the number that went into the moderate risk increased a little bit. Okay, even in the no risk group, that increased a little bit. So the people's opinions, students' opinions in 12th grade are not quite as strong as they were in 9th grade. Now what our chi-square test does just is test whether or not there's differences between the 9th grade and 12th grade. It doesn't do it in a direction. But this test here, the test for trend, will actually evaluate whether or not I have an upward trend in the plot the way that it's plotted here. So it might be interested in a one-sided test, not a two-sided test, especially in this context here. And JUMP has the ability to do that test. Again, the Cochrane Armitage trend test. We can get that from the red pull-down menu. It actually gives me two different p-values here. The one-sided one is going to be the one that doesn't have the absolute value here. So the analysis or the p-value for a test of trend in this plot, that p-value is going to be 0.0005, it looks like, which is less than 0.05. So I can say that the opinions in grade 12 have slid back a little bit compared to grade 9. So this test here is kind of a nice little test. It's not very popular. Not very many people run this test, but it is available in our JUMP software. All right, let's go back to this kind of a standard test of association here. So here I have collected data on the state of Minnesota, and they're called the HIV and AIDS surveillance reports. They are provided every year from the Minnesota Department of Health. The data that I have here is not real recent, but I did, if you go out to stats class, I did provide some links for some updated data. So some of the things that we could look at here, so again, this is for the state of Minnesota. If you look at some of the stuff on gender and race, so let me click on that. And again, this is a report that's provided by the Minnesota Department of Health. And this looks like it's from 2017. I just looked in the 2018 data. They're going to provide that here, I think, next week. So the 2018 data isn't quite ready yet. So we'll just use the 17 data. So here's just some side-by-side pie charts, I guess. In 2017, there were 209 males that contracted HIV and only 74 females. So a chi-square test here we could use that to determine whether or not the patterns on the left-hand side are different than the patterns on the right-hand side. So in other words, do males contract HIV or get HIV differently than females in the state of Minnesota? So you would just take these numbers and drop those into JUMP. You're going to have to do these based on counts, though. So when you're putting this into JUMP, don't put in 39% for white, but what you're going to have to do is there was 209 individuals that, males, that got HIV in 2007. 39% of them, so I guess it's about 81 or 82 male whites, I guess, got HIV in 2007. So if you're putting this into your software, the chi-square test is based on counts, not percentages. So you'd have to do that math before running that test. You could also, in the one that I presented in the notes, you could also do that same thing across race. If we just flip through here quickly, you can see that the reasons, or how, people contract HIV is different between the races. So whites looks like that on the screen. African Americans. Here's Hispanics. I think the African born is the one that looks really different. So you can take these numbers and do those if you want. You can either do comparisons across, you can do that across gender, or you can do it across race. And again, I did in section 8 or in handout 8.3 or example 8.3, you can see that I did one across the races. So I took that data, brought it into JUMP. So there's that data in JUMP, again, based on accounts, approximate counts, because there's a little bit of rounding there in the percentages. And then I can look at a mosaic plot. And you can see that the reasons how people get HIV is very different across races. The biggest one is the African born here. So if I did a chi-square test of independence here, the hypothesis would be, are the reasons for getting HIV different across races? In this test, I would clearly have a p-value less than 0.05 because of that African born group. So even if you took that updated data and did that analysis inside of JUMP, you'd probably have the same findings, that there's definitely differences and they're due to that African American group. Here's example 8.4. I think I'm going to have example 8.4 just be your quiz that I want you to do. So I'll post that. So I'll leave example 8.4 to you. I'll do one more example here at the back here. So I'll run quickly. I'll do example 8.5 for you just to show you one more example. So I got to take this data that I have presented here and get that into JUMP. And again, I need that data. So let me go ahead and show you how to get that into JUMP quick. Going to have to hand type this one in, I guess. So let's get a new data table. I'm going to have a column there for the type of arrest. Well, how about the treatment program? Let's do that first. So again, this is data from the state of Minnesota on the sexual treatment program. We kind of looked at that data earlier. And this will be type of rearrest. And then we'll have a count variable as well. So my levels there for the treatment program are never entered. I have a quit or terminated. And then I have a completed. Okay, and then I got those again. So I got those. I'm going to have those for the sex arrest. So let me go ahead, maybe enter in the type of arrest here. So these were rearrested for a sexual crime. Do a little copy and paste here. And then I am going to have those same three again. Never entered, quit, and completed. And then I'm going to have other rearrest, I guess, is the next one over. And then I'll have no rearrest as well. And that'll be never entered, quit, or completed. And then the counts there will be 53. Looks like I'm going down in my table, 26, 12. Okay, so those are those numbers. Again, we might be able to order these treatment programs. That might be appropriate. Those do have order to them. So never entered might be the first one there, then quit, and then completed. So we can put those in a particular order. Fit Y by X here. Treatment program is going to be my predictor. My response is type of rearrest, and then count here. That's what that data would look like in a mosaic plot. The no rearrest is the red boxes here, so we want that to be high, and it looks like it is indeed highest for the completed group. I have my contingency table down below there, and then also my test. So if we go back to page 13 here in the notes, answer those questions down there. What is the p-value from your test in the context of this problem? What is the practical interpretation of this? So my p-value for this one is going to be, again, less than 0.0001. So let's go ahead and p-value is very small. Less than 0.0001. I guess less than. So the practical interpretation here, practical I can spell, interpretation. Practical interpretation is that whether or not they complete the sexual treatment program has an impact on the type of rearrest. Type of rearrest or not rearrested, I guess. So there's an association there between whether or not they went through the sexual treatment program and that recidivism rate. What is gained by running a chi-square test of independence? Again, because a chi-square test of independence actually is going to go beyond just this data here. It's going to try to expand that scope of inference to what would happen if these numbers were collected again or changed. So it takes into consideration that random variation between collecting data over repeated collections of the data. Their research question here is one-sided, so they're asking about a decrease in recidivism. We actually did a two-sided test, so the chi-square test of independence is a two-sided test. So you actually might want to run a Cochrane-Armitage test on this just because they're interested in a decrease in recidivism. So the test that I ran doesn't address that question exactly. The chi-square test of independence is just a test of association. It does not have a direction attached to it. So that's why in my conclusion down here I said has an impact on the type of rearrest. I can't say has caused a decrease just because a chi-square test of independence is not two-sided. Okay, I think we got to the end of Handout 8, and that'll be good enough for this video. Thanks a lot for listening, and we'll see you in class.